Okay, we're in section 27, and what I would recommend to do is look over the code, and you should be getting more familiar with coding. And I can't say this enough times, you really have to start becoming familiar with coding, like even if it's just primitive coding, but coding in general. Now, I'm not saying memorize, I'm saying become familiar, right? So what am I familiar with? Resetting, defining x as a variable, assigning f of x as a function, differentiating, differentiating derivatives, taking a second derivative, plotting, looking at limits, so forth and so on. All right. So why would you do that? Well, the reason to do that, if you look back over the problem set we just did, we would need to be able to do that, right? We would need to be able to do that. For example, on something like this over here, you should be able to plot this out. Yeah, if you plot it out, there's going to be a maximum here, a minimum here. You know what? I want to do this problem. Let's go to Sage. Let me clear the screen. And let me see if I've learned anything. And what I'm going to do is I'm going to reset. I'm going to let x be a variable. And that variable would be x, right? And then I'm going to say f of x is equal to 1 minus 9 divided by x plus 3 divided by x squared. Okay, that's done. Now, what do I want to do? I want to take its derivative. You know what I'll do? I'll plot first. Plot f of x. I'll do the simplest plot possible. I don't like the picture. All right, I'll do it again. All right, and this happens all the time. You can get a picture and say, what is that thing? I don't see anything there. And there's a point to that. I'll tell you why. Sage is simply saying, I have no idea what you want to look at, but let me do this over here. I'm going to go back to this, and I'm going to plot it again. But now I'm going to say x min is minus 10, and x max, right? Watch this, is, I don't know, let's take a look at my picture here. And this is part of your learning curve. I'm going to say 10. Let me see what that picture looks like. I still don't like it. Here's the deal, though. It does keep the x is now between minus 10 and 10, but now I'm seeing these numbers here, and they're huge. This is 1.6 times 10 to the 7th power. That's 16 million. That's crazy. I don't want that. So let's go back. And what I'm going to do is I'm going to refine. I'm going to say y min, sorry about that. Y min is, and maybe I'm cheating a little bit. I'm looking at my picture. I'm going to say maybe minus 7. And I learned I can't say by cheating, by looking. I shouldn't say cheating. And Y max to be 7. And I'm hoping when I do this over here that lo and behold, I get a graph that's much more reasonable over here. Now, Sage has a lot of things I could deal with, right? Including finding these mins and maxes. I don't think I see this one over here. And I'm wondering if I type my function in right. I'm going to look back at my function. I'm not getting that picture. And I think I made a mistake because I didn't get the same picture, did I? So let me go back to my Sage, and I want to see, what did I do wrong? I see it now. I defined f of x incorrectly. Let me go back over that with you. I said x squared. It's actually x cubed, right? So I'll just redo it. And I'm going to redo the plot now too. And now it's much better. All right, I'm seeing it much better. It's exactly like the one we have in the paper over here. This is part of your learning curve. Now, again, I've been doing students for a very, very long time. A lot of students don't believe this is part of the learning curve. They think it's unnecessary. You're not going to know this information unless, of course, you can do it yourself. That is try. You need to start trying. All right, so what I'm going to do is I'll close this out. I want to go back to Sage. And I'm realizing I got to do some things over here. And let's point out what we need to do. All right. So one thing I need to do is take the derivative. So I'm going to do that. I'm going to say diff, D-I-F-F. You know what? I want to assign it to another function. So I'm going to say df of x is equal to diff, D-I-F-F, of f of x with respect to x. And I want to display df. I want to see if I got the same answer. And what do they give me? Well, I'm looking at their derivative, my derivative. I'm wondering, did I get the same one? And let's take a look at that. Yep, it's the same thing. The only difference is I factored it. All right. I think to put the second derivative down too. Let me see if I can do that. So I want to do ddf. That's a second derivative. I'm just defining a new function, x. And what's that going to be equal to? Well, the derivative, diff of df of x with respect to x. All right, let's display it, ddf. See if we got that right. And let's see if we got it. I got the first term. They just multiplied it out. And I got the second term. All right. Now I'm looking back at my picture and I noticed that they say a local minimums occurred at -1. And let me look at that. That's a local minimum over here. And I'm going to say, yeah, it looks about right. But I want to see if I can do this in Sage. All right. I want to see if I can do it in Sage. So what I'm going to do is I'm going to say, I'm going to solve. Right. And what am I going to solve? I'm going to solve df of x equal to 0 for x. And I want to see what happens. I might be surprised, by the way. Well, it says the plus or -1. So let me point out what I mean by this. I'm looking at my picture. This is the picture we're looking at, and the piece of paper over here. And -1's a maximum, and at 1 is a minimum. Now, when I say that, they're relative. Now, I want to find out what their values are. For example, I actually look at f of -1. And to me, it looks around 7 point something. Well, let's see what happens. Wow, it's exactly 7. And I'm looking at f of 1. And to me, it looks around -5 point something. Wow, it's exactly -5. All right, you get the idea. Now, I'm going to also say that I'm interested in what's called a point of inflection. So I'm going to solve, and I'm looking at my picture, by the way. I'm going to solve ddf, that's a second derivative, x for 0. And who knows, maybe you can't do it. What does it do? Plus or minus square root of 2. Now, you should have an idea what square root of 2 is, but if you don't, square root of 2 is, like 1.4. And where would 1.4 be? Over here somewhere. Now, what do I notice over here? Concave up, concave down. Now, minus root 2, it's over here some way. Concave up, concave down. I'm expecting that. Let's do the point of inflection, though. What's it going to be? F of square root of 2. Let's see what happens. And it gives me a kind of a nasty number, by the way. But, certainly if I want to approximate that, I'll show you what I do to do that. And so it says -4 on the y. So square root of 2. And I'm getting a better idea now. So -4.3. So over here somewhere. That's a point of inflection right over here. Let's do that one now. So we get, and that's 6.3. And that's over here now, right up there. All right. Again, it's important that you realize this stuff needs to be done by hand. What are we doing now? Learning how a tool does those problems as well. Are tools easy to use? Not really, but they're easier than doing things by hand. I think you'll agree with that. Thank you.